In this analysis, they're asking us to tell which of the forces that are acting on the rod will produce torque. Okay, and they're giving me the axis of rotation. Remember that the axis of rotation is the same pivot. So they're giving me two forces, force 1 and force 2. What force out of the two is going to cause rotation?
F2.
F2. That is correct. So yes, it is correct. I better use the mouse. Okay, now it's working. So this one is not going to cause rotation. This one will do it, okay? I'm going to send you an activity where you have to do this kind of analysis about telling the forces that will actually cause rotation and ignoring those that are not going to. That's very important, honestly. Now let's work with an example. The example that I did in class, as you saw, it was only one angle, but this time I have three angles, okay? This time I have three angles. So to start with the problem, we first need to, of course, read the word problem, that is, calculate the torque for each force acting on the bar. Assume the pivot is located at the point O. In what direction will the object rotate? So the first thing I'm going to do is I'm going to place the pivot. There it is. There it is, my pivot, okay? So I need to say, I need to calculate the torque, but before I go into that, I need to see what forces are going to cause rotation, okay? So take a look to this force. I know, wait. That I have a problem with the iPad, I don't know. I have to restart the app. Finally. Okay, good. Now I can continue. So one thing that you need to know, guys, one thing that you need to know, all forces, listen to me, all the forces, when they pass through the axis of rotation, they're not going to be doing torque. Okay? So let's analyze the first one. The first one has an angle of 45 degrees. And these are my components. What happened with the two components? One is going left, one is going down, but what happened with the two of them? Where in what point are they being applied?
In the pivot.
In the pivot. So if the force is applied in a pivot, remember, no torque is done, okay? When the forces pass through the pivot, no torque is done, and it applies to all forces. So for the force one, because it is applied in the pivot, remember when I tried to close the door and I couldn't because the force that I was applying was passing through the pivot? Exactly the same way it happens. So every time a force passes through the pivot is not going to do rotation. In the case of the force one, even if you see it in the picture, force one is not doing torque, therefore you don't need to get it. So force one can actually be completely dismissed. Okay, this one is not doing torque. Why? Because it's passing through the pivot. Now we're going to focus on the other two forces. We're going to focus on the force of 25 Newton at an angle of 35, which is force 2, and the other force that is 10 Newton at an angle of 23. So in the force of this one, in the force 2, what type of angle I have over there?
Vertical.
Okay, I have a vertical angle. So if I have a vertical angle, that's going to define many things, you know. So let's see the components. I'm going to have a vertical component, and I'm going to have a horizontal component. Okay. Okay. So of the components, which one am I going to ignore?
FY.
Of the two forces, of the two components in force 2, which force is not doing torque?
F2x.
F2x. Okay, I'm not going to use it. Because I'm not going to use it, I'm going to erase it because it's not doing torque. So I need to get the F2y. F2y is the vertical component. For vertical angles, how do I get a vertical component? What trigonometric function I have to use for a vertical component for a vertical angle?
Cosine.
Sine.
Cosine. Cosine of the angle because it's a vertical angle. Remember, for vertical angles, the vertical component is with cosine and the y component is with, and in the x component, sorry, is with sine in vertical angles. In horizontal angles, this thing is very slow. Have no idea why. Anyways, in horizontal angles, The y component is with sine and the x component is with cosine. It's a normal angle. In this situation, we have a vertical angle. So the component in y must be calculated by using cosine. So slow. Okay. Remember that. That's why we always analyze the type of angle that we have. So now let's analyze the first three. Okay, in the first three, I have my y component, more or less like this. And I have my x component in this direction. What component is not doing rotation? What of the two components is not doing rotation?
X.
X. So X, not gonna use it. Okay. Now, what type of angle is this?
Horizontal.
So it's a horizontal angle. So because I'm gonna be using only the y component, f(3y), I'm gonna be using what trigonometric function? Sine or cosine?
Sine.
Sine. Okay. So we already did the analysis. So we can start working with that problem. So the first thing that I will do is the free body diagram. So in my free body diagram, I will include the forces that will do torque. So I have my pivot in this position. Okay. And I have my bar, this. Now, remember, I'm not gonna use the forces. I will use the components of the forces. So in this point, and going up, I'm gonna have my component y of the force 2. And in this point, but downward, I'm gonna have the component, the vertical component of my third force. Okay, because it is a free body diagram, I also have to include the distances, the lever arm. So my lever arm is going to be, I don't know why this thing is so slow. So I'm gonna have two lever arms, one to the force number 2 and the other to the force number 3. More or less like that. So D2 is equal to 2 meters and D3 is equal to 4 meters. Okay, so that's my free body diagram. That is my first step. I don't know the values of the forces yet. Okay, so I need to get them. Since the two of them they are already forces. Take a look. They are already forces. They are not masses. So I don't need to get the forces. I don't need to get the forces because those forces are already in Newton. So the first step that we used to do, that was converting from mass to weight, we're not gonna do it in this exercise because the forces are already in Newton. Now, from the prior analysis, we know that we need to get the F2y with cosine and F3y with sine. So I'm gonna calculate the components, the vertical components. That's going to be my other step. Okay. So I told you before, for F2y, we're going to be using cosine. And for F3y, we're going to be using sine. I do it like that because I don't want to forget. But the analysis was done here initially. Xavier.
Miss, I just want to be sure. Can you remind me why we like cancel the first like angle, the 130.0 Newton?
This one, because the two components in here, the two components are going to pass through the pivot. So they're not going to be able to rotate the bar. I mean,
Miss,
you can do the test with your pencil. Get the pencil from the eraser, which is the pivot, and apply a force upward and downward from the pivot. You will see that no rotation is going to be done. Try and you will see.
Miss, we cancel because it touches or it works with the pivot, right?
Exactly. When that happens, no rotation is done. It's like when you apply a force on it's like you try to open the door by pushing the part of the hinges. Okay, you're never gonna open the door from the hinges. You open the door from the knob.
Yes, this is true. Thank you.
Okay. So now we focus on getting the components, okay, the vertical components. So as we did the analysis before, F2y, we're going to be using cosine, and F3y, we're going to be using sine, and we're going to use the values of each force, okay? So let's focus on the first one, that is F2y. F2y is going to be equal to the hypotenuse, which is F2 times cosine of the angle. Why? Because it is a vertical angle. The other component, F3y, is going to be equal to the force 3 times sine of the angle. The reason is because this is the horizontal line. Okay. So we're going to make substitution of our givens. Force 2 is equal to 25 Newton. And the angle is 31 degrees. How much is this?
1.43 newtons.
My other force is equal to force 3. That is 10 Newton. Okay. Sine of the angle, in this case, the angle is 23 degrees. How much is that?
3.81.
3.91 Newton, rounded. So now we have the forces. Now we have the forces that are doing torque. Now, let's calculate the torques. The first torque is going to be torque to Y is going to be equal to the force to Y times the lever arm 2. The other torque, which is torque 3Y, is going to be equal to force 3Y times the lever arm of the third force. According to the free body diagram that we did, D2 is 2 meters and D3 is 4 meters. So we make substitution of the givens. How much is this?
42.86 Newton meter.
We're gonna see the direction later, okay? Now let's get the other torque is 3.91 Newton times D3, that is 4 meters.
15.64 Newton times meter.
15 point.
64.
Okay, the analysis of the directions. The first two, the force 2Y is gonna do a positive or negative torque.
Positive.
Positive. Okay. How do we say positive?
Counterclockwise.
Counterclockwise. Okay. The second force. What kind of torque is gonna do?
Negative clockwise.
Okay, negative or clockwise. Now it looks good. Now, what comes next?
It's our net.
The net torque. Okay, so the net torque then is gonna be equal to torque to Y plus torque 3Y. This is equal to 42.86 Newton meter minus 15.64 Newton meters.
27.22.
27.
0.22.
Because it's positive, you don't forget to write the sign.
Positive. Confirm.
Huh.
But twice.
Yes, guys, please don't forget to write the signs. From the exercise that I just did, do you have a doubt? If you are too shy, you can write it in the chat. Now, what happens here? What do we do in the first place?
The analysis of the angles.
The analysis. Okay. Now I'm going to apply another force right here and another force right here. I'm going to call this force 1, force 2, and force 3. Vaya. Okay. Of the three forces, which one is doing torque?
First one.
1.
Only force 1. Force 3, no, because it is applied in the, right on the pivot. And force 2 also is not doing torque because it passes through the, I mean, if you project this force, if you make like a projection of this force, you're gonna see that it's going to pass through the pivot, okay? So in that case, also it's not gonna be doing torque. So these forces, we're not gonna use them. Okay, I just put them there to make you feel confused. Now, yeah, sometimes it happens that I put more forces than you have to use. So you need to be analytical. Now, what happens with this force? This force is gonna have components. It's gonna have a component in X and a component in Y. Okay. You can put it here, okay, or over there. It doesn't really matter. What matters is where the force is going. Okay, so the y component is doing torque?
No.
No, it's not. So you need to focus only in the x component. What type of angle is this?
Vertical.
Mhm. This is a vertical angle. So for the first one, we have a vertical angle. So how do we get the component f1x? With what trigonometric function?
Sine.
Cos.
Sine or cosine?
Cosine.
Sine.
Cosine.
For x in a vertical angle is going to be sine. Two reasons. This angle from here is the same angle here. So this is in front. If it is in front, we use sine. That's why. So those are the kinds of analysis that you have to do with torque. I know that is a little bit more complex, but you need to be careful. Also, keep using the pencil. Keep using the pencil to discard those forces that are not